Hello everyone. So today we are going to discuss about data warehousing of module 3, chapter number 3 in the textbook. So data warehouse is an organized collection of integrated subject oriented databases designed to support decision support functions organized at the right level of granularity and provides clean enterprise-wide data in a standardized format for reports, queries, and analysis, and has to be constantly kept up to date to be useful, and it should have clear metadata. So data warehouse is physically and functionally separate from an operational transactional database, and creating a data warehouse for analysis and queries represents significant investment in time and effort. And these are some of the benefits of data warehousing, and it supports business reporting and data mining activities, facilitate distributed access to up-to-date business knowledge for departments and functions, simplifies data access and allows end users to perform extensive analysis and present a competitive advantage by facilitating decision making and helping reform business processes, enables consolidated consolidated view of corporate data, oil oil all clean and organized, enhance customer service and satisfaction, enhances overall IT performance by not burdening the operational database used by ERP and other systems. So these are some of the characteristics of data warehousing: subject oriented, integrated, time oriented, non-volatile, summarized, not normalized, metadata, web-based, relational, multidimensional, client-server model, real-time or right-time. So we have different types of data warehouses. So one is for the enterprise, that is called as EDW, and data mart. So this is a departmental data warehouse. So this is a conceptual framework for data warehouse. So data sources are from the operations, for example ERP systems, legacy systems, point of sale, RFID systems, web usage, external source. And data transformation: select data, then extract data, cleanse the data, compute data fields. So once the data is gathered, so it has to be transferred, and we have to extract it, clean it, compute it, and integrate data, and we have to load the data. Okay, so after all the extraction processes, cleaning, okay, we have to present in a most useful way. So that is called as recognizing data ready for analysis, one for each department or one or more whole enterprises. Okay, and finally it has to produce a reporting tool, that is OLAP tools, reporting tools, and dashboards, queries, mobile devices, data mining, customer applications. Okay, so the final step is the output of the framework. And some of the questions arise in data warehouse architectures are: which database management system should be used, and will parallel processing or partitioning be used, and will data migration tools be used to load the data warehouse, what tools will be used to support data retrieval and analysis. So this is an example of EIL process, that is data integration and extraction, transformation and load process. Okay, so we have an packaged application, legacy system, and other internal applications. So all are given here, and we are extracting information that we have gathered from different input sources. Then we have to transform, clean, then load that data into the data warehouse, and from there it is given to the data mart. So there are two approaches. So data warehouse development approach. One is Kimball approach and Inmon approach. So the scope is one subject or functional area, and it is for complete enterprise data needs, and functional area reporting and insights, and deeper insights connecting multiple functional areas. And it is a decentralized management. It is a centralized management, and time is, it is very low to medium, but it needs very high time, and cost is very low, and cost is very high if we compare to the enterprise, and size is small to medium, but and here it is medium to large. Approach is, it is applying bottom up, and it is top down. Complexity is very low, fewer data transformation, it is very high, and data standardization. Technology, smaller scale servers and databases, here industrial strength. So this is an example of star schema. So we have an order data. It has an item ID, sales person ID, region ID, period ID, total sales and sales quota. So again we can categorize into item ID and item name, region ID and name, salesperson ID, and this is how we can represent the data. So best practices for data warehousing is the project must fit with corporate strategy, and it is important to manage user expectations, and the data warehouse must be built incrementally. Only load data that have been cleaned and are of high quality, and enabling real-time data updates for real-time analysis and real-time decision making is growing rapidly. And concerns about real-time BI is not all data should be updated continuously. Mismatch of reports generated minutes apart may be cost prohibitive or infeasible. Read Continental case for more. Thank you.